Hello, it is I, your internet friend, Robert Gadarian. And today we are looking at more NumPy arrays. We've had two very long videos, and now we're going to have two demo videos of us doing stuff. This video will include some other functions that we can use, and we'll see them work. So let's do it. So we're going to use some NumPy calculations. How do we calculate things on 2D arrays? And how do we represent this data? We've already talked a little bit about the XY coordinate data set, where we have a very long table, and you can think of it as a table, where the 0th column is X and the 1th column is Y. So the first column is X and then Y. You could flip those, but it's nice to think of the data as, well, we have many points. So those would work really well as rows. And then this must be columns, and that's what we're looking at. You could flip this. 1, 1, 1, 2, 2, 3, 4, 5. That would work. This is a valid NumPy 2D array. I discourage this, but if this is how your mental model can work, that's fine. I could also even flip this is Y and this is X. That's fine. This is our design. We have complete control over the entire universe, which is pretty cool. Okay, so we have a concept of all of these points. I can just say there's 5 of them. And we have a point C. Now what we want to do is calculate the distance from all of these points to that point. That sounds terrifying. What would be our results? Our result would be a NumPy array of distance. I don't really know. I'm just going to make up numbers 5, 10, 7, 6. There's 5 points, and there's a resulting NumPy array with 5 indexes, each with some kind of index. So here's an interesting thing we can do, is that these rows have numbers that we know. Apparently we have 4 points here. Well, so do these. 0, 1, 2, 3, and I'm just going to just make that one disappear. Those indexes will match. So we can say that index 0 is going to be to that data point. So I'm going to make one of these disappear to make sure they match. And index 1 is for this point. Index 2 is for this point. Index 3 is for this point. And these distances will relate to these points with these indices. We're keeping everything in order, so this can work. Okay, so how can we do this? Well, we have the mental model. We have some code. We have a seed that I'm setting to something. I don't really care. I'm going to have 10 rows. That means I'm going to have 10 points. I'm going to have 2 columns, X and Y. And I'm going to have random numbers between 1 and not up to and not including 100, because this is np.random.randint and not the terrible NumPy or Python built-in random.randint, which includes the high point. So much anger. Let's see our data, which is named data. Aptly so. Okay, there's our points, and even from last time we have them plotted. This is vestigial from then. And I think I can delete them all. Yay, neat. Okay, so I want to get the distance from all my points and C, some other point. So we actually eventually want to say every point that is within M from point C, where M is some value. And we'll do that in a moment too. Okay, we have a distance formula. You've probably seen this before. The square root of x2 minus x1 squared plus y2 minus 1 squared. It actually does some triangle-y stuff for us, which is pretty great. And let's do that. So I'm going to say distance formula. Formula. D is the square root sqrt of stuff. We'll see it. But I'm doing everything kind of index wise. So first let's do y1 plus y2, or y1 minus y2. How would we do that? Well, we would have our data, and we need to have our point. I'm going to say point x is equal to somewhere in the middle there, maybe right in the middle. Point y equal to 50. So that is my point C. I only have one of them, so I can make them into just that. And then I have many of the rest. So I need to get all of my x points and do x2 minus x1. So I need all my x points, so all rows, but only the 0th column, those are my x points. Minus point x. This is arguably a scalar, and that will be applied to the entire data set. So first of all, just to show you that this does work, I'm going to say that this is my array, and I'm going to say array minus point x will I haven't run this yet. Play. Data minus point x will subtract 50 from every single one of my points and return a numpy array of the same length with all those subtractions happening. Groovy. Now, that is a numpy array, so can I do this? I needed to square it. Squared. I could use np.pow. That would work too. I believe this works. It does. I'm shocked. Cool. So that is, if we go to our distance formula, x2 minus x1 squared. Okay, now I have to add that to y2 minus y1 squared. It's kind of the same thing, where we're going to say plus, now I need y's and point y squared. Bang. I'm actually just going to run this in my interactive console because I haven't saved this into a variable yet. And that seems to be working. Now I need to get the square root of this whole thing. There are some Python functions. I believe that the normal Python square root would work. We do want to keep this all in numpy to keep it fast. We can say np.sqrt, which will do square root on the function, on the whole thing, as we'd kind of expect. And then this is going to be called points or distances, or just d, distance. I realize this is running off the screen. We can use a feature. This is actually already in. I think this will work because if we're in braces like this, white space becomes pretty flexible. I think that it's going to allow me to do this. And you can see it's highlighting, very importantly, that I have the matching brackets. I think Python will let me do this. It does. Huzzah. Okay, those are all my distances. What do they look like? Print distance. Boop. I'm going to print out my data and then distances and print data. I'm going to print a line. Otherwise, it's impossible to read, as we saw. And I'm going to say that, yeah, this first point seems very far away, so 48 seems about right. I could do the math by hand. Elements 0, 1, 2, 3, 4, 5 is very close to the middle. 0, 1, 2, 3, 4, 5. 17 is my smallest number. So that seems to work too. So I believe this is working. Smell your data. Doing the math by hand will guarantee that it's right. This feels right to me. Okay, cool. That is the distance from all points. And I did that in 2 lines of code. Groovy. But I had to plan it out. Again, write it down. It will save you time. But what I want to do is find the one that's the closest. How do I find the one that's closest? There is an icky way we could do this with pure numpy, where it would say find the maximum distance and then slice a bunch of stuff. Honestly, iteration's a better answer here, where we're going to use a loop that we've used a number of times before, saying that at first our index is going to be 0. We're just assuming that the first point is the closest. And as we go through, we're going to see if the current point is closer than our known maximum. And once we, this is a proof by exhaustion. Once we go through the entire list, we will see which one is the biggest. And then we can use this index, because I'm doing this by index, to print out the points that are the closest, which is cool. I'm going to show you that in a moment. So first, I'm going to say I in range of the length of distance. Then I'm going to say if my max index, or the data at max index. I'm only tracking the index. So I'm going to say distance at my max index is less than the current distance at I. So moving all the way through, I found a new one. It's bigger than my biggest, so this I must be my new max index. I could track the value inside of it, but I don't have to. I can just pull it out of the array. And pulling data out of arrays is free. I can tell you that right now. So print max index is index. Index is blah. I could actually be very fancy and decimal format it. Why not? Format max index. And this should print out 5 for me. 6. Let's make sure that's the right data point. Print. The points are, and I'm going to just put that in a new line. I don't want to use print formatting for this because it's icky. And I'm going to say from my original array, and remember, going back to my iPad, I can say my data, I have this index and this index matches. I can go back to my original and show the points from that are the closest. So I can just say, I believe it's called data. Yep, data at max index. And print distance is, and then I can just do the placeholder thing here, dot format, and then put in distance. This is really distance is at spot max index. If I run this, the points are 99, 15. That seems suspicious. And the distance is 60. That smells wrong all over. So we have this distance array, and it's saying it's 60 and not 17. If distance, let's see, I'm debugging here. Distance at max index is less than distance I, then we track I. Oh, I found the maximum. I found the point that is furthest away. I want the least. There we go. And I realized I wasn't showing my code, but you could pretty much imagine what I did. And that's 17. What we expected. And it's funny that they're side by side. Neat. So we're doing things by index. And that is why we can pull out all this data so nicely. So we found the one that's closest, but we had to iterate over the distances to get the distance index. And those indexes matched up with my original points index. Very interesting. Try this out on your own. You can see it's about 30 lines of code, but it's picky, and it's good to try. Okay. So we want to do some other calculations. I've already actually done this now that I think about it. Given a 2D array, manually get the sum of all the elements. So I can write that up in seconds because I've done this a million times. And I'm going to do this by using 2 for loops, just to refresh ourselves really quickly. What will happen is I'm iterating over these first as my outer index, and this is my inner index. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. And I'll get a total sum. And of course, I can pass it a slice and do all kinds of things. So for x in data, this is really a row. I'm going to use iteration style, which was from the first lecture this week. For column in row, total plus equals my column, which is really the data in that row. Total is equal to nothing. The sum of nothing is nothing. Then I can print out my total sum of all the points, which is a little bit meaningless in this case, but something that we can write. And it's just a few lines of code of iteration, and you get it. It's nice. But there's got to be a better way. Oh, I didn't show that. You heard me talk through it. And Do we need to do this ourselves? Well, we don't. There is a cumulative sum that will get the cumulative sum in each point, where if we had an array of 1, 2, 3, 4, it'd be 1, and then the second one would be 1 plus 2, which is 3, and have that, and then 3 plus 4 is going to be 7, and store that. And this is better served as an example. D is equal to a range, p dot a range, up to 10, and d dot cumulative sum will give you 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 2 is 3, 3 plus, let's get the a range in there too. Let's print out d, and then d dot cumulative sum. You can line them up. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and we can walk through it that way, which is actually really interesting if you're trying to get a total population graph. That's how they've been tracking the COVID cases. Every week they add in a number, and then you have this ever going up graph. That's a cumulative sum. You could get that for free. You can do that with cumulative product. You can transpose it. This is, if we had a 10 by 2, it can be a 2 by 10 for free. You can do that by hand. It's actually a really good thing to try doing, and it's free. We can also fill out the entire thing with a value. If you wanted an array of 100 by 100 filled with tens, I'd use np.zeros to have 100 by 100, and then just say dot fill 10. Done. There are some things that we can do around axes, though. And these are a little bit sticky. We can get a sum along a single axis, and the product along a single axis, which is really handy. 0 is the first axis, so that means it would be going down the rows. So in terms of code, I have my data. If I said just data.sum, I give it just sum, it will give me a scalar, or a single value, which is the sum of all the points. I can also say 0, give me the sum of all the columns. So this is like having a grand total in a spreadsheet down at the bottom. I can also say go across the first 0th is your rows, first is your columns. Give me the sum of all the columns. So I have 10 data points here, so now I have an array of size 10 as the sum of each column. Neat, one command. Not too bad. So try that out, get a feel for it in case it ever becomes useful. Those two things you can do by hand fairly easily too. So in summary, think about how we'll represent our data, walk yourself through it, and NumPy has a bunch of tools for us. We just have to be aware of them and know how to use them. So have a good day.